All right, so earlier we mentioned that if we know the population itself is quite heterogeneous, then we can perform the strata by random sampling to subdivide the population into different strata so that within the stratum it is homogeneous, and between strata they are quite different, they are heterogeneous. Then stratifications would be most efficient. So I'm going to show you some of the example why this is so important, that when we stratify the population, we need to properly implement the stratification so that to achieve a more efficient estimate for the population than a normal simple random sampling. So let's look at an example 4.3. Consider a population that we have the data 1, 2, 3, 7, 8, 9. So the population size is 6. Okay. We can easily calculate the population mean, adding up together and divided by 6. We find the true population mean is 5, so male is 5. We can also calculate the true population variance. Sigma square is indeed equals to each of the data point to mean taking square and divided by 6. So the true variance is 29 out of 3. Okay. Let's draw a simple random sample with size 4 out of the population size 6. Then we can estimate we can find the variance of my y bar under the simple random sample. We learned that using the final population correction factor multiplied to the true variance square divided by n. Right? So in this case, we find the variance is 29 out of 30, slightly less than 1 for my simple random sample variance. If we stratify the random sampling into 2 strata, so let's say I know this is the population, and then I know 1, 2, 3, they're closer to each other, 7, 8, 9, they're closer to each other. So I can stratify them into 2 strata with stratum 1, 1, 2, 3, stratum 2, 7, 8, 9. Okay, now within each of the stratum, we perform a simple random sampling. Okay, N1 and 2 both equals to 2. So to make up the total sample size equals to 4. So I like to compare the simple random sampling variance with my stratifications. Okay, so in stratum 1, we have the population 1, 2, 3. We draw a simple random sample of size 2 within them. So we would have 3 samples drawn, 1, 2, 1, 3, and 2, 3. Then we would have the mean, 1.5, 2, and 2.5. In stratum 2, we have the population 7, 8, 9, so we perform the same. So we would have the mean 7.5, 8, and 8.5. Okay, and then we calculate the overall mean, and that becomes y1 bar to y2 bar, and then weighted by their population size. So this is like an average of the two because of the same size of the populations. Okay, so now we would have y bars stratified, estimate or calculated from strata 1 and strata 2. Now we have the y bar stratified mean, the distribution of it. Okay, so as a summary, if y1 bar is 1.5, y2 bar 7.5, then we can have the stratified y bar equals to 4.5, and this would be the distribution of all of the possible y bar from the stratification. Now with this, we can plot out the 9 cases of the y bar. So we can find that 4.5 appear once, so probability would be 1 out of 9. 4.75, 2 of them, so 2 out of 9, etc. So now we have a probability distribution for my y bar from stratifications. Okay. With the probability and the value, we can calculate the expected value of my y bar under the stratified random sampling, and we find that equals to 5, which is the same as the population mean, 5. So we know that under stratified random sampling, this is an unbiased estimator. Now we can estimate we can find the true variance of this y bar because we have all of the values, so that's going to be a true value. So after calculation, this is 1/12, 1 out of 12. So we can see that from this stratification, the variance 1/12 is significantly smaller than 29 out of 30, which is slightly less than 1. So under this scenario, we can see that if we carefully separate the strata into, separate the population into strata, so that between strata they're quite different, but within strata they are similar, then as a result, we can find an unbiased estimator with a very small variance. In this case, we are concluding this is a very precise estimate with this variance. Okay, so we properly divide the population into strata that are internally homogeneous, and between strata they are heterogeneous. In this case, we would have a very good estimate of our estimator with the variance, which is quite small, and we have very efficient estimator. On the contrary, I like to look at example 4.4. If the population is divided into two strata, which is not carefully implemented. So let's say strata 1 we have 1 to 9. Stratum 2 we have 3, 7, 8 from the same population. Then we perform the same within the strata 1, we have the sample mean. Strata 2, we have the sample mean. Then we can calculate the overall distribution of the y bar under stratified random sampling. And within the two strata, we can also calculate the true variance. Now we can let's try to use the overall variance formula that we learned in this chapter. So the variance of my y bar under stratified random sampling equals to variance of my stratum 1 plus variance of stratum 2, but weighted by the populations W1 square and W2 square. Okay, so the square would become 1/4. So overall, the variance of my y bar under stratified random sampling is 13 out of 12. This is not very good because this is slightly greater than 1. This is worse than how we did from the simple random sampling. Not even be very, very close to compare to the properly implemented stratification scheme. So it shows that the variance of y bar under this case is larger than the y bar simple random sampling. The division of strata did not consider the fact that the y values vary greatly within the strata. So we can see that within stratum 1, 1 to 9, they are not very homogeneous. 3, 7, 8, they are not very homogeneous. So it shows, this example shows that if we perform stratified random sampling, and if we are not carefully implement the stratification or divide them into the strata, that may result in an even higher variance of my y bar estimate. Okay, so it shows that just by looking at the sample variance in stratum 1, the variance is 30 out of 3, which is so large for the element 1 to 9 were collected. So this is not very wise if we do not carefully divide the population into different strata carefully. We want them to be homogeneous within stratum so that we would have a better estimate of the variance for the overall. Okay.